Hello, and we are back today with exponential functions, growth and decay, day 2. We're really going to be working on compound interest today. So hopefully you have contacted your teacher during their office hours on any questions you had from yesterday. But if you have not, make sure that you do so you can understand everything we're giving you. All right, so today we're going to look at exponential growth and decay models. And this model right here, A sub t equals A times the quantity 1 plus R quantity to the t. The A of t stands for amount after t time periods. The A is our initial amount. The R is our growth rate. If our growth rate is bigger than 0, it's a growth. If the R is less than 0, it's a decay. And we'll talk in a minute about that 1 plus, 1 plus the R. And then T is our exponent, and that's the number of time periods. Now, the 1 plus R, that is our B value. 1 plus R means that, let's say we go out and we buy a shirt for $20. And that's 100% of our purchase. Well, we know that we can't just get away with spending $20. We're also going to have tax in there, which is going to add on another percent, let's say 5%. So when we purchase our sweater, it's going to consist of 105% of the price, which is the same thing if I move my decimal and make this, instead of a percent, a decimal, I'm going to move it twice, which is 1.05. And that's what we're looking at right here. We have our 1 plus our rate. Now, along with adding to something, so if things are going to increase, such as if I put $100 in the bank with interest, in a year, I should have maybe $102 if I don't add or take anything out. But we can also have B equals 1 minus R if something depreciates. Depreciates. So that means that the B amount is going to be less than 1. So the cost is going to go down. So if we have people moving out of a city, there's 20,000 people there right now. Next year there's 18,000 and so on. It's going to depreciate each year. So let's look at a problem. You put money into a fund, $1,000, that pays an annual interest rate of 5%. So we know that our equation is A of t equals A times, and since it pays interest, we're going to gain money, so that's going to be 1 plus R to the t. So now we need to figure out what these values mean. So if I put in $1,000, that's going to be our A amount. 5% is our R, but we can't just say, oh, that's 5%. We have to make it into a decimal. So that's going to be R equals 0.05. And then in our first question, it says after 10 years, which is going to be our T value. All right, let's put everything in and see what happens. A of t equals 1,000 times 1 plus 0.05 to the 10th power. Make sure that you put everything in the calculator exactly as you see it. You remember, you cannot multiply these two together and then take it to the 10th power. That is completely wrong. The only thing that's to the 10th power is the 1.05. So when you put this into your calculator, you should get $1,628.89. Anytime we work with money, make sure you round to the 100th. Two decimal places. Okay, that's one of the biggest mistakes that Algebra 2 kids make, is they're like, oh, I'm just going to round it to the 10th, but what does 1,628.8 mean? Nothing. You have to have 100th there. All right, let's go on to the next part of the problem. We're going to double our money. So if we started out with $1,000, how much money would we get if we doubled it? Well, that gives us $2,000 equals 1,000 times 1.05, and I'm looking for how much time that's going to take. So to solve that, we want to get the exponent by itself on this side. So the 1,000 does not have an exponent, so I can divide each side by 1,000, which gives us 2 equals 1.05 to the t. And that 2 right there means doubles. So now I'm going to show you a couple of different ways that you can do this problem. Later on, we will figure out how to change the form of this, but right now we don't know how. So one way is to guess and check. To guess and check, we're going to look for values of t. So the question above, 10 years, it gives us $1,600. So maybe I would put in 17. Well, if I put in 17, I get 1.05 to the 17. That gives us 2.29, which is too much. So let's try 15. If I do that, I get 2.07, which is still too much. So if I try 14, that's going to give me 1.98. So somewhere in between there, and we'll just go ahead and round up. So we're going to say that it's going to take approximately 15 years. Another way that you could do this problem is by the graphing calculator. Make this y1, make this y2, and see where they intersect. And they're going to intersect at 14 point something, which is going to be approximately 15 years. Okay, let's look at the next one. All right, Johnny bought a new truck for $20,000. It depreciates. Depreciate, what does that mean? Depreciate means decrease. It decreases by 3.5% each year. How much will the truck be worth in 7 years? So my equation is going to be a sub t equals a times 1. This time, since it's decreasing, we're going to subtract that r to the t. So now let's figure out what everything stands for. This right here is going to be my initial value. That's how much it cost. Over here, my rate is 3.5%, I have to make that a decimal. So my R is 0.035. And then we have our T, which is going to be 7. So let's plug everything in. My A value is 20,000. 1 minus 0.035. And my T is to the 7th value, to the 7th exponent. And so put everything in your calculator at once. 1 minus 0.035 to the 7th. And we get, shh, Abby.
Abby.
Shh. 15,585.52. So just in 7 years, his car went down in cost, how much it's worth. All right, now we're going to look at compound interest. Most of this looks the same. The P, of course, is our initial amount. Okay. The 1 stands for we're getting 100% of our value plus an interest rate. Okay. And that rate is always going to be represented as a decimal. Now, here's the new. We have this in. That means not everything is just compounded once a year. This one means it could be compounded once a year, so I'd put a 1 there. It could be compounded semi-annually, so I would put a 2 there. Quarterly, 4 quarters in $1, that would be a 4. Monthly would be 12. Weekly, 52. And daily, 365. Now what you should notice is that the N is located in 2 spots. It has to go underneath the rate, and it also gets multiplied by your given time in years. So let's look at our problem. A equals P times 1 plus R over N to the NT. Now we're going to figure out what everything is. You deposit $9,000. That's going to be our P. Initial amount. 1 plus. In an account that pays 1.46%. Well, that 1.46 has to be made into a decimal, so I have to do 2 decimal places. So it's going to be 0.0146. Annual interest, find the balance after 3 years. That's going to be my T. Now, I also have quarterly. What does quarterly mean? Quarterly means 4 times per year. So I have a 4 going into 2 spots, once in the denominator and once out here with the exponent. So you're going to put this whole thing in your calculator exactly as you see it. Don't try to make any shortcuts. Just put it all in at once. When you do that, you should get $9,402.21. Don't forget 2 decimal places because we need cents. All right. That concludes our lesson for today. What does an exponential graph look like? Well, there are 2 different graphs. For growth, it's going to start low and then increase. And for decay, it's going to start high and come low. All right, name some things that might use exponentials? Well, compound interest. What's happening with us right now? Viruses, right? Doctors use it a lot. All kinds of banking. Okay, what is true for a growth? Your B value has to be greater than 0, or greater than 1, sorry, greater than 1. And for decay, it has to be between 0 and 1. And what does the A value mean, or the P value mean? It's always the initial value. All right, so I hope that this helped you with your lesson. If you have any questions, don't forget to get a hold of your teacher during their office hours. And your assignment is on Big Ideas 6.1b. See you soon. Bye-bye.